Alright, so for this video, we're going to discuss Statistics 1 paper, which is actually the May-June 2021 session, paper 5.3. Alright, okay, so let's start with question number 1. Alright, so for question number 1, they give us the heights in centimeter of 160 sunflower, and the results are summarized on the following. Okay, so generally, if you have a look for the graph that they provide us, it is actually the cumulative frequency curve. Okay, and then from the cumulative frequency curve, they want us to answer the question. All right, so let's have a look. What is the question that they want us to answer? All right, so maybe I put it smaller. Okay, so for question number A, they want us to estimate the number of plants that is less than 100 cm. Okay, so for less than 100 cm, very easily, you can straight away look for 100 from the x-axis, because for the x-axis here, they are talking about the height of the plants, which is cm. So you have to try to read from the graph where's the 100. So I think this is 100, right? Okay, so I already draw the lines prior before I record this video, okay, so that it is easier for us. Okay, so you just draw a line from 100, go up, touch the curve, and go to the left, okay, to read the value from the y-axis. So you can see that the value of y-axis that we get is actually 60. So that means there are 60 plants, which is less than 100 cm height. Okay, so very easy now. So you can just make sure that you write out the correct answer. The number of plants will be 60. Okay, then now we continue further, we go to part number B. So for part number B, they ask us to estimate the 65th percentile of the distribution. So when they ask us to estimate 65 percentage or 65 percentile of the distribution, means that they want to know the 65% of the total plants. Okay, and they want to know that 65% plant is what height, it is in what height. Okay, so to estimate the value, okay, from the graph, first of all, 65 percentile, you need to take 65% multiply with the total number of plant, which is 160. Okay, so you need to know what is the value first. Okay, and you should get 104. So which means that you need to read the value from the graph, start from the 104. And please take note that this 104 is actually our cumulative frequency. Okay, so at the 104 from y-axis, so if you read it carefully, this will be the value of 104. Okay, so again, you draw the line, go to touch the curve, okay, and then read the value at the x-axis. All right, so if you read the value from the x-axis here, all right, I'm having I have to read the value very carefully. If let's say this is 120, okay, this is 140, okay, which means that one box before 140 will be 136, where each single box here, the small box here, denote 4 units for the x-axis. So from here, I can see that it's actually 134. Okay, so you can straight away write out the answer. All right, so the 65th percentile. Okay, the height at the 65th percentile is actually 36 cm. If you want to write out, you can write out 136 cm. All right, okay, so this is how we do the part B. Okay, so let's continue to part number C. So for part number C, they are asking for interquartile range. All right, so for information, right, interquartile range means IQR. So IQR, you need Q3 minus Q1. Okay, so first of all, we need to know what is Q1. So Q1 is actually the 25th percentile. All right, then again, of course, you need to calculate the location first, and also the Q3 is actually the 75th percentile. So just like part B, what you need to do is like you take 25% multiply with 160. Okay, then this is at 25% multiply with 160. So some of you might take 160 divided by 4 for Q1 also can. Then for Q3, you can take 160 divided by 4 multiply with 3. Okay, so for 160 divided by 4, you'll get 40 lah. All right, and then for 160 divided by 4 multiply with 3, then you get a location for Q3. Q3 is 120. So please take note that all these are not value. It is just a location that you want to read the value from the graph. All right, so I will start with Q1 first. Q1, okay, so Q1 should be 40. Okay, so 40 means cumulative frequency, the cumulative frequency at 40. All right, you draw a line, touch the curve, and then reflect it down to the x-axis and read the value. All right, so this is one box before 80, therefore I know that the value is 76. So Q1 value will be 76. All right, so maybe for this one, I write as the 40th data, okay, right from the cumulative frequency curve. Okay, then the value itself for Q1 should be 76. And then how about for Q3? So for Q3, we need to read the value from 120 from cumulative frequency. So from cumulative frequency, 120 is this one. Then again, start from the 120, you draw a line, go and touch the curve, and then you try to read the value that is reflect to the x-axis. All right, so again, if you look at this box, okay, it is like maybe in the center or slightly more than the center. Okay, then if this is 120, right? This is 120. This is 140. Okay, 148. It is between 148 and also 152 lah. All right, so maybe for me, I'll write as Q3 is equals to 150. All right, okay, so to get the interquartile range, you need to take 150 minus 76, and therefore you should get a 74 as your interquartile range. All right, so for this question, generally we need to get the value from the cumulative frequency curve provided by the question. All right, so and this is how we actually find it out. Okay, so now we continue with question number 2. Right, so they give you a random variable x that can take all these values from -2 until 2, and they also give you the probability distribution of x with different value for probability as well. Okay, but you can see that they didn't list out all the probability lah. They just mention it as p, then 0.1, and also the q. Okay, then from here they give you one information. Given that the probability for x greater equals to 0 is equals to 3 times of x smaller than 0, and they want you to find the values of p and q. All right, so generally you should use all the information that you know that is related to probability distribution, okay, to get the p and q. So to get the p and q, generally we need to form two equations, and then we will solve it simultaneously. All right, so maybe first of all we will start from this one. This is the information that they give us. Okay, so for probability that x greater equals to 0, it is equals to 3 times of the probability that x smaller than 0. So where's the probability that x greater equals to 0? So this one, 0.1, q, and also q. This 3 belongs to x greater or equals to 0. So that means you're having 0.1 plus 2q. And it is equals to 3. 3 times of what? 3 times of the probability that is smaller than 0. So smaller than 0 means both value here, the p here. So it will be 2p. All right, so you're having 0.1 plus 2q equals to 6p. All right, so if you want, you can rewrite it as 2q equals to 6p minus 0.1. And this will be our very first equation. All right, okay, then how can we get the second equation? All right, so for the second equation, actually we know that the summation of probability, right? So I think we know that the summation of probability, it should be equals to 1, right? This is a property for the probability distribution. So the summation of probability means that you have to add all these probability together, and the total of all of these value are 1 is 1. So you're having 2p plus 0.1 plus 2q equals to 1. Okay, then you can rephrase it again. All right, so you can rephrase it become 2q equals to 0.9 minus 2p. And from here, you get the second equation. All right, so I think very easily you can see that I have two equations here. Therefore, to get the value for p and q, right, you just need to solve the simultaneous equation. All right, so you know that equation number 1 is equals to equation number 2. All right, so you just try and see whether you get 0.8 equals to, 8p equals to 0.8 or not. Oh, sorry, it is not 0.8, it should be a 1. Okay, and then p is equals to 1 over 8, or you can write it as 0.125. All right, then after that, you can get the value for q. So the value for q will be 0.9 minus 2 multiplied with 0.125 divided by 2. I'm substituting the p into the equation number 2. All right. Okay, so from here, if you didn't do any careless mistake, then the value of q that you get should be 13 over 40, or it is 0.325. Okay, so if you want to double check and see whether your answer is correct or not, maybe you can try to substitute the value of p and also the value of q into here, and you add them together and see whether are they equals to 1 or not. All right, so this is how we get a value for p and q. You solve simultaneous equation, right? So we come to question number 3. All right, so for question number 3, there's a volleyball team and also the hockey team. And then you have 6 members from volleyball team, and they are summarized, their data are summarized like this. Okay, the heights of them. And then you're having 11 members from hockey team, and also they summarize their height in this data. All right, and then first of all, they want you to find the mean height of all 17 members of the club. So if let's say they want to find the mean for both groups, all right, so you need to actually combine the data for both teams. So that means to find the mean, you need to have summation of x plus the summation of y, so that you find out the total height for all the 17 members, and then divided by 17. Okay, so I think this is quite straightforward. Right, so the summation of x will be 1050 plus the summation of y is 1991 divided by 17. Okay, so if I press calculator, I'm getting a fraction which is 3041 over 17. Or you can change it become 3 significant figure, which is 179. Right, so this is actually 3 significant figure. Okay, so this is what we have for part number A. And then if you proceed to part number B, okay, so let's have a look for part number B here. They want you to find the standard deviation, all right, standard deviation of the height of all the 17 members of the club. Okay, so what is the standard deviation formula when we want to combine the data for both teams? All right, generally the formula will be you need to have the summation of x squared and also the summation of y squared, means the summation for x squared, the data square for both teams, then divided by 17 minus the mean, okay, for all the 17 members, and then you square it. All right, then of course, to get the standard deviation, you need to take the square root. Okay, so summation of x squared and summation of y squared is already been given in the question. So you just put the value in. Okay, plus summation of y squared is 366,400. Okay, then divided by 17. minus the mean. All right, so the mean for the 17 people that you calculate just now is from part A, which is 3041 divided by 17, and then you square it. All right, so just a reminder for this mean, right? Please don't use the value of 179 because the 179 is a value that we already round it off. Right, so it is not the original correct value for the mean, not the accurate value for the mean because we already draw it off. Therefore, when you want to substitute all the mean value, right, you have to ensure that you are using the original, the very original value for the mean. So for me, we are having this fraction, which is 3041 divided by 17, then you square the mean. Okay, so if you press the calculator and you didn't do any careless mistake for this question, you should have this as the value. And we will correct it to 3 significant figure, which is 30.8 as your final answer. Okay, so question number 4. Right, so we are having 3 pair 6-sided dice, and then each with the faces marked 1, 2, 3, 4, 5, 6. All right, and are thrown at the same time repeatedly. Okay, so for a single throw for the 3 dice, the score is the sum of the numbers on the top faces. Okay, then first part, they want you to find the probability that the score is 4 on a single throw of the 3 dice. Okay, so when you throw the 3 dice for the first time, for one time, they are asking for the sum, which is 4. Okay, because here they already mentioned the score is the sum of the numbers on the top faces. So that means you are having 3 top faces, right? When you throw the dice, the 3 dices in a single throw. And then what is the probability that you will get 4? The sum is equals to 4. All right, so maybe you can try to write it out. Score is 4. Okay, so for this question, because you are having 3 dices, so that means maybe you have to try to think, all right, what are the outcome, okay, or what are the result that you will have the sum of the number that give you a 4. Okay, so maybe to get a 4 from a dice, you're having 3 dices, right? So to get the sum which is equals to 4, we actually don't have a lot of choices. We are having 1, 1, 2. Okay, because we are having the first dice is 1, second dice is 1, the third dice is 2. So the sum of these 3 values here is equals to 4. Correct or not? So before the one, besides the 1, 1, 2, what else do you have? All right, so we are having you can have also 1, 2, 1. Right? Because all these 3 numbers, when you total them up, it is still equals to 4. And the other one will be 2, 1, 1. So besides these 3 outcomes, then you won't have any other values anymore. All right? Okay, so to get the probability for the first result here, okay, to get the 1 from a dice, you have 1 over 6. To get 1 from the second dice, also 1 over 6, because they are independent with each other. All right? So you just need to consider every single outcome here for every single dice. Then to get the 2 from the dice is 1 over 6 also. So each of them is 1 over 6. The same things apply for the second value, the second result, and the third result. Therefore, I'm not going to repeat anymore. I will just straight away write multiply it by 3. Okay, then from here, I will get the value which is 1 over 72. All right. Okay, then now let's continue to part B. Okay, so for part B, they are asking for the score of 18 is obtained. Okay, just now we find out the 4. Okay, the score is 4. Now they want to ask the score of 8 obtained is obtained. Sorry, 18 is obtained for the first time on the 5th throw of the 3 dice. Okay, so first of all, for this question, actually they are having 2 stages here. I don't know whether you can see clearly or not. The first stage is actually you need to find out the probability for the score of 18, and after that you need to find out you get the score of 18 not on the first throw, but it is on the 5th throw. All right, So I put it into two stages here lah. So the first stage is for single throw, what is the probability that you get 18? And after that, after you find out the probability for a single throw already, then only we consider how to get the probability for getting the 18 on fifth throw. Okay. All right. So we focus on single throw first. So to get a single throw with a score of 18, again, you just do like what we have in part A lah. So probability for the score of 18 is it equal, what is it equals to? So what kind of result will give you the sum of 18? All right, so I think there's only one result, which is 6, 6, 6, 6 plus 6 plus 6, you get 18. No any other result, okay, that give you the sum of 18. So if you try to calculate the probability, it will be 1 over 6 for first dice, 1 over 6 for second dice, and also 1 over 6 for third dice. Okay, and after that, you should get the value, which is 1 over 216. Okay, so please take note that this is actually the probability that you get the sum of 18 on single throw. Okay, on one single throw. Okay, then now we proceed to the second part of the question. They are asking for fifth throw, first time of 18 on fifth throw. So maybe you can write that the 18 is obtained for the first time on fifth throw. Okay, so that means what? That means you want to throw the dice, the 3 dices for 5 times. Okay, so for the first time, you didn't get the 18. So for first time, you didn't get the 18 means that the value should be 215 over 216. Because you know that on single throw, to get the 18 is 1 over 216. So if let's say you don't get the 18 on a single throw, that means it will be 215 over 216. Okay, then for the second throw also, you didn't get the 18, so also 215 over 216. Same thing happened for the third one and also the fourth. And then on the fifth throw, you get the 18, so it will be 1 over 216. So please take note that when you see this kind of formula, right, the steps, generally it is part of geometric distribution. Okay, that means you throw until the sum of 18 is obtained, something like this. All right. Therefore, if let's say you don't want to list out your steps like this for every single throw, then you can use the concept or the idea of geometric progression, which is which is Q power n minus 1. So n minus 1 is 4 lah. Your n is 5 here. Okay, and then 1 over 216, this is P power 1. All right. Then from here, if you press calculator correctly, then you should have 0.000454. So I will leave my answer like this into 3 significant figures. Okay, so this is what we have for question number 4. All right, so question number 5. Okay, question number 5 talking about the length of the leaf, and you can see an important keyword here, which is normal distribution. So from here, you know that this is a normal distributed question. All right, and then we are having a sample of 500 leaf. Then find out that 42 are less than 4 cm long and 100 are more than 10 cm long. Okay, so this is the information that they give us. Then they want you to find the estimates for mean and also the standard deviation of the length of leaf from this type of tree. Okay, so generally, if let's say x denotes the length of the leaf, right? So it is normally distributed, and you actually don't know what is the value for the mean, and also you don't know what is the value for the standard deviation. All right, so from here we are going to form two equations so that we can use them to find out the mean and standard deviation. All right, so first of all, let's have a look for first information here. They said 42 are less than 4 cm long. So x is the length, right, of the leaf. So x less than 4. And how many of them is having the length less than 4 cm long? So you can find out that 42 out of 500. Therefore, the 42 out of 500, it will be actually the probability or the percentage. All right. Okay, so this is the first information that I can get from from our paragraph here, the question. Then for the second one is this one. 100 are more than 10 cm long. So if you try to write it out, okay, the length which is more than 10 cm, you are having 100 of the leaf. So 100 out of 500. So from here, you can see that you get two information. All right, so you can actually try to form the equation from these two information, and then you can try to solve simultaneous equation to get the mean and standard deviation. All right. Okay, so let's continue with this. All right, so since we know that it is normally distributed, so we want to standardize it. We want to change it become Z. So 4 minus mu divided by standard deviation, and I should get 0.084. Okay, sorry, 0.084. All right, so if let's say I want to find out this value for the Z, okay, from table, then maybe before I find out the value, I will try to draw a diagram. Okay, for normal distribution, this is 0. Since we are having the sign of Z smaller than and also the probability, this one denotes the area smaller than, and the area is a small area. That means our value, okay, for 4 minus mu divided by standard deviation should be a negative value because it is before the 0. Can you see that? So it should be a negative value. Okay, it should be at the negative side. All right, and then if I sketch out the diagram, it should look something like this, where this is actually 0.084. Okay, so from here, I'm going to find out what is the value for 4 minus mu divided by standard deviation from the normal distribution table. All right, okay, so we are having a table here. Okay, maybe I can put it smaller, or maybe I can just show it here. All right, so they are asking for 0.084. Okay, this is the area or probability. So probability part denotes all the part in the center here actually. Okay, and if you look for all the value inside here, you will see that there's no value which is equals to 0.04, and all the values are more than 0.5. Okay, so to find out the area for this one, the value of Z for this area, generally we are looking for 1 minus 0.084. Okay, so which is the complement area for this 0.084, and you will get the value which is equals to 0.916. So instead of 0.084, we will look for 0.916 from the table. All right, okay, so where's 0.916? So if you look at it very carefully, this value is the value that's smaller than 916 but closest to 916. Okay, and after that, to make it become 916, you need to add 13. Okay, so that you will get 9160. All right, so where's the 13? So 13 is here. Therefore, if you look at the value from the table, it is actually 1.378. Okay, so for this value, it should be equals to 1.378. And because of from the diagram that you draw, you aware that this should be a negative value, right? So you should put a negative value in front, which is negative 1.378. All right, so once you get this value already, then you can try to make it as a formula. So we are having one first formula, which is actually mu equals to 4 plus 1.378 sigma. Okay, I rephrase everything and I make the mu on the left hand side. Okay, so you're having mu equals to 1.378 sigma. So this is my first equation. So I'm going to do the same thing for the second equation. All right, so for the second equation that we have just now, Okay, maybe I need to rewrite it again. So we are having actually the probability that x more than 10 cm, it is equals to 100 divided by 500. And again, you need to standardize it, right? So z greater than 10 minus mean divided by standard deviation, and it is equals to 0.2. All right, okay, next. Again, before I want to find out the value from the normal distribution table for the value of z, I will want to sketch the diagram again. 0 is the mean in the center, and then for this equation here, I'm having z greater than, and 0.2 again is a smaller area. Therefore, I should expect that actually my mean, sorry, my value of z is on the right hand side. So which means if I draw it out, it might look something like this. 0. This area is a small area on the right hand side of z, which is 0.2. And this value itself should be 10 minus mu divided by standard deviation. So from this diagram, you should aware that the value of z that we found later, it should be a positive value. Okay, so 10 minus mu divided by standard deviation. Okay, so what is the value of z that we have? Again, you should look for 0.2, right? Okay, so if you look for the area, all these are the probability, okay, the area. So you will see that there's no 0.2. All the values are more than or equals to 0.5. Okay, so the same process again. You need to take 1 minus 0.2 and then you get the 0.8. You need to find the complementary area, okay, for 0.2, which is 0.8. All right, so where is 0.8? So you try to look for a value smaller than 0.8 but very close to it. So I think this is the one. So 7995, you need to add 5 at the last digit to make it 0.8. Therefore, if you look at the value here for the z, it will be 0.842. So it is equals to 0.842. And from the diagram, you can see that it is after the 0, which is actually a positive value. Therefore, this is actually a positive value. Okay, then again, from here, you continue to rephrase your equation again, then you will get another equation, the second equation, which looks something like this. All right, then you can try to solve simultaneous equation now to actually get the value for mu and also the sigma. All right, so since 1 equals to 2, and therefore you should get 4 plus 1.378 sigma equals to 10. All right, then if you continue from here, you rephrase everything and try to get the sigma, right? So the sigma should be 10. Sorry, should be 100 over 37 if I put it in the fraction form. Or you can rephrase it into 3 significant figure, which is 2.70. All right, so this is actually the answer for sigma. And then to get the answer for mu, you need to substitute the sigma value into either equation number 1 or equation number 2. But again, when you want to substitute the value to get the mu, right, please make sure that you substitute the fraction so that you can get the most accurate answer, okay, according to the marking scheme to the final answer. Okay, so if you substitute it and you didn't get any made any careless mistake, for the mu value you should get 1429 over 185, or you should get 7.72. 3 significant figure again. All right, so as the answer for mu. Okay, so this is how we actually solve this question. All right, okay, so this is part A. So you form the equation by using the information that they give you, and then you try to solve the simultaneous equation. Okay, so let us proceed to question number B. Okay, so question number B, I'll put it here. Okay. And we need the table also, so maybe I'll bring this first. All right, so for question number B, now again, they are still talking about the length of the leaf for different types of tree. And again, you still see the keyword normally distributed. And now we are having a random sample of 800 leaf from this type of tree. Okay, so they are asking how many of these leaf would expect to have length is cm between this and also this length. All right, so again, our variable that we defined earlier, right? The length means x. Okay, so we are interested to know what is the probability for the leaf with length between mu minus 2 sigma and also mu plus 2 sigma. After I find out the probability, then I will want to multiply it with 800 to know how many leaf belongs to this length one. Okay, so let us start. This is how we write the correct symbol. All right, x is between this length and also this length. After that, because of we know this is a normal distribution, therefore we need to standardize it. All right, so how to standardize it again? Okay, so we need to minus the mean where we don't know the mean yet. All right, divided by standard deviation. So the same thing happened for this. Okay, so for this part number B, we still don't know what is the mean and standard deviation. Therefore, we still assume that it is mu and sigma. Okay. Then if you try to simplify it, you will get z, which is become between -2 and 2. So to find this probability, it is actually z smaller than 2 minus the probability of z smaller than -2. Okay, so to get the probability of z smaller than 2, then you should look for this value. Okay, 2, right? So the probability will be 9772. Okay, so we will continue from here. It will be equals to 0.9772 minus, when they are looking for z smaller than -2, this is equals to z greater than 2, the area. If you draw the diagram, right, you will see that the symmetrical property tells you that the same area here or same probability here. And to get the z greater than 2, in our table, they only provide us smaller area, right? So it is equivalent to 1 minus z smaller than 2. So which means that I'm having 1 minus 0.9772 in this case. And then again, by just pressing the calculator, okay, that you should get the answer, which is 0.9544. Or you can change it become 3 significant figure, which is 0.954 in 3 significant figure. Okay, so this is how we actually use a normal table to find the probability. All right, but this is not the final answer yet because they're asking for how many of these leaf. So if you want to find out the number of leaf, you should take 800 multiply with the probability that you have. Okay, then you will get a value lah. So the value, it should be around 763.52. Okay, so you can round it off, becomes 763 leaf. Or some of you might want to rephrase it, becomes 764 leaf. Okay, both are correct and both are accepted in the marking scheme. All right, so you can write any one of the answer here, either 763 or either or 764. All right, so this is what we have for question number 5. Okay, so we will discuss question number 6 now. All right, so they are asking for arrangement, so you can highlight the keyword arrangement. So again, when you see this arrangement, means that generally in your steps, we are using the P, NPR, or maybe the factorial sign. All right, so this is about the arrangement here. Okay, so we are having 11 letters in total, and then the word is actually requirement. Okay, so again, every time before we want to start arranging all the letters, we need to consider and see how many types of letter we have. So for R, we have 2 R. E, we have 3. Q, we have 1. U, 1. I, 1. Then M is 1. N is 1. T is also 1. So if you try to double check and see, you should have 11 in total, 11 letters in total here. Okay, all right. So for arrangement, right? So you want to arrange 11 letters, so it should be 11 factorial or 11p11 divided by. Okay, since we are having identical letters here, so we are having 2R and also 3E. Therefore, in our arrangement, we need to divide 2 factorial and also 3 factorial. And therefore, you should get 3, 3, 2, 6, 4, 0, 0. Okay, so this is how we complete the part A for question number 6. All right, so for part B, how many different arrangement again? So please highlight the word arrangement again. And here they are saying that 2 R's are together and 3 E's are together. So for now, they are assuming that the R cannot be separated. So that means for R, we are treating them as one item. And then for the E also, all the E here cannot be separated as well. So we are also treating them as one item only. And then we're having Q, U, I, M, and T. Okay, so let's count now. How many items do we have here? So we're having one item. So 2, 3, 4, 5, 6, 7, 8. We are going to arrange only 8 items here. So we will have 8 factorial. No need to divide any identical terms because of all the R here, I didn't consider their arrangement. That means we are making them as one group. It is one single item. All right, so we no need to divide the repeated arrangement for both R and also no need to divide the repeated arrangement for all the E. Okay, so the answer is very straightforward, which is only 8 factorial, and we should get 40320. Okay, so let's continue to part C. All right, so for part C, again, highlight the word arrangement one more time. So still considering the factorial or P and PR as our solution. Okay, and it is still the same word, which is requirement. Then they are having exactly 3 letters between the 2R. All right, so they are asking for the number of ways that we want to have exactly 3 letters between the 2R. So usually for this one, maybe there are many ways that you can solve it, definitely. Okay. But for me, maybe I want to list out, okay, all the possible arrangement here, but not every single arrangement, but a general overview, okay, for arranging the R with 3 letters between them. Okay, so first, I might have the first R here, the second R here. Okay, and then this is the first position. So second position is where? The second position will be R is here, then got 3 letters in between, then this is the second position. Okay, then how about the third one? So the third one will be this one. Okay, then if you continue, this is the fourth, then this is the fifth. Okay, and this is the seventh. Oh, this is the sixth, sorry. All right, so maybe we count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, then you have to put in one more. All right, then we still have another one. Just now we have 6 position for R already, right? Then we are now having the next one, which is the 7th position of R. Okay, so now I try to figure out first how many position of R that I can put it in these 11 letters here. So there are 7 different cases, right? Okay, so we are having 7. All right, so maybe I can write out here. Like, this is actually for the position of R, then dash, 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 R. Yeah, all right. Then after that, let's say my R is here and this one. So how many empty space I need to arrange my other letters? So I'm still having 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to arrange all the 9 letters here. Therefore, multiply with 9 factorial. But from these 9 letters, is there any repeated or identical letters or not? So from the 9 letters here, we are still having 3 identical E, correct or not? So we need to divide it by 3 factorial for the identical E. For the R, because we already fixed them at a certain position, we are not arranging them. Therefore, we no need to consider the 2 factorial divided by 2 factorial. Right? Okay, because we fix it position by position. We are not arranging in general with all the 9 letters. So we no need to divide it by 2, 2 factorial. So for this example, we are having 4, 2, 3, 3, 6, 0. So this is how we actually get the answer for part C. Okay, then now we continue to part D. Okay, so for part D, they are asking for 5 of the 11 letters in the word requirement are selected. Then they're asking for how many possible selections. So again, highlight the keyword selection. So usually selection, we are talking about combination, and the steps or maybe the solution that we involve usually is NCR. Okay, and then they are asking for restriction also here. They want to have at least 2 E and also at least 1 R. All right, so maybe for this example, we need to list out all the possible cases. Okay, so again, before we list it out, then we list out again. We are having 2R, 3E, then 1Q, 1U, 1I, 1M, 1N, 1T. Everything is 1 here. But we are having 2R and also 3E. Okay, so first case, just bear in mind that you want to select 5 letters in total, and out of these 5 letters, right, you must have at least 2 E and also at least 1 R. So maybe I start with the basic one first. I'm having 2 E and 1 R. Therefore, I still have 2 empty space, which is not E and R. Okay, so this is my first case. And then for the second case, maybe I will increase the value, the number of R. Okay, so maybe I'm having 2E and then 2R. So the last letter here should be a letter that's not coming from E or R. So this is my second case. So please take note that all these 2 cases here, right, it fulfill the restriction, which is mentioned in the question, at least 2E and at least 1R. Okay, do I have any other possible cases or not? So the next one, maybe I want to increase the value of E, which is E, 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 R, 3E, and also 1R. All right, so if let's say I'm having 3E and 1R, that means the last letter here, we want to select from the letter which is not E and R. Okay, then continue. I might also have the case E, 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 and then R, R. All right, then there's no more E for me to increase the value, the number of E and also the number of R anymore. So I think this should be all the possible cases. Okay, then now we want to put in the selection. All right, so for first case, we are having 2 empty space here, right? So these 2 empty space must be chosen from these letters. So how many letters here? There are 6 letters here, right? So the step should be 6C2. We are not going to consider the R and E anymore. All right, because if let's say we consider the R and E into our selection, all right, it will not be correct, okay, that we are having EER only, right? So these 2 letters that I list out should be from the letters which is not E and also not R. Okay, then continue to the case number 2. So for case number 2, we are only having one empty space, which means that you want to select one letter from the 6. So it should be 6C1. Same thing happened for case number 3, one empty space, it is 6C1 also. And for the last case, there's no empty space, right? So this selection itself belongs to one case, so equals to 1. Okay, so what am I going to do now is I calculate the value of combination for every single cases here. And after that, to get the final answer, I need to get the total for all the cases. So the total is 28. So the number of combination that fulfill the restriction here will be 28 cases. Okay, so we come to the very last question for this set of paper. Okay, so they are talking about, they give you us a two-way table. All right, and then they are saying that the total number of household is 800. Okay, then they are talking about the quality of broadband service, right? So you can see that you are having the broadband service according to the village, and then their response are summarized in the following table. Okay, so this is a two-way table, right? Then usually before we found a two-way table, if possible, I usually will suggest you to find out the total for every single group. So as an example, you should have 225 for the total of breakdown. So you add 75 plus 118 plus 32. Okay, then you should get a 225 here. And then after that, for the next group, you will get 440, 225, then 440. Okay, then for the last group, you're having 135. Then you can just double check and see that the total for all this group is it equals to 800 or not. So the 800 will be the grand total, right? So all these are the group total, like the total for each category or each village, all right? Okay, then for the quality of broadband service, also the same for excellent, good, and poor group. Please find the total for each of the group. Okay, then we are having 310 here. For the second group will be 355. And then for the last one, it should be 135. So again, you can double check and see the total for the broadband service, right? The quality of the broadband service, is it equals to 800 or not? So just take note that 800 will be the grand total. And then all the total that are listed out here are the group total, okay? The total for the different category. All right, so now for the first question here, what they want us to find is find the probability that a randomly chosen household is in Shan. And so you see the word and means that they are looking for the intersection. So it is from Shan and also has poor broadband service. So which means for this question itself, they are asking for Shan intersect with poor. Okay, so which cell we should look at? So you look for the Shan and also poor, which is 40. So 40 is the value, okay, divided by the grand total 800. Okay, when you want to find the probability, you are divided it by total, right? The value 40 divided by total. So for this case, we are going to divide it by grand total 800. So the value that you get should be 1 over 20. Right, so this is first question. Okay, then we go to part number 2. Question A, part number 2. All right, so they still want you to find the probability, and they said the chosen household has good broadband service. Given that, so I need you to highlight the word given that. So this keyword actually tells you that they want you to find out the conditional probability, and the household is in Shan. Okay, so to find the conditional probability means that Shan, you know that the household is in Shan first, followed by good broadband service. So when you write the symbol, it should look something like this, conditional probability symbol. And after that, the formula for this will be good broadband service intersect with Shan. and divided by the probability of shunt. Okay, so this is how we actually find out the conditional probability lah. So good intersect with shunt. So where is good and intersect with shunt here? Okay, so for our case, we are having 177. All right, so according to this formula, right, it should be 177 divided by 800. Okay, but actually I can ignore the 800 because later the denominator, I also want to divide it by 800 also. So I usually didn't write it out. Okay, so I'm looking for good and shunt intersect with shunt, which is 177. And then the probability of shunt. So what is the total for the shunt village? So it will be 440. So instead of divided by 800, I will divide this by 440 for the conditional probability. Or maybe some of you might want to write out 177 divided by 800. Okay, then over 440 divided by 800. So you can see that the 800 will be cancelled off. All right, so usually I didn't write it out. Okay, so it is not wrong if you want to write out, because no matter how, eventually the 800 will be simplified. Okay, so the final answer will be 177 divided by 440. Okay, if you want to keep it in the fraction form, this is the final answer for fraction form, or you can change it become three significant figure, which is 0.402. Okay, right, so this is what you have for 7a part 2. Okay, then we continue to question number B, 7b. Right, so for 7b, they are talking about the whole ARCA. There are a large number of households, and the survey shows that 35 of the household have no broadband service. 10 households in ARCA are chosen at random. Fewer than 3 has no broadband service. Okay, so again, for this question itself, a larger number of households, okay, are chosen at random. And then in the question itself, they are asking for fewer than 3 of these 10 households, something happened to them. So for this case, is having no broadband service. So when you're having this kind of structure of question, generally it is binomial distribution. And we are talking about the number of households that have no broadband service. Okay, and from here you should know that X is binomial distributed. So usually for binomial distributed, you need to look at the structure of the question itself to identify that it is binomial. Okay, so we are having 10 households in total, and we need to put in the probability that has no broadband service. So no broadband service means you're having 35%, which is 0.35. And they are asking for the probability of X fewer than 3 households. So the number of households fewer than 3, which is less than 3. Okay, so for binomial distribution, your X can start from 0, 1, 2, until 10 for our case here, because the n here is a 10. So the maximum X can be 10. So when they're asking for X smaller than 3, right, you should start from 0. So what is the probability for X equals to 0? So 10C0, 0.35 power 0, 0.65 power 10. Then plus 10C1, 0.35 power 1, 0.65 power 9. And also 2, 10C2, 0.35 power 2, 0.65 power 8. Okay, then here, because of the sign here didn't include the 3, therefore we should stop at X equals to 2. Alright, then by just pressing the calculator, you try to get the final answer. Okay, and of course I want to keep my answer in 3 significant figure, therefore the answer should be 0.262 in 3 significant figure. Okay, right. This is B part number 1. And then we continue to B part number 2. Okay, so now instead of 10 households chosen at random, they are choosing 120 households. So we are still having the same distribution, which is binomial. And then you're having 120. The probability of not having the broadband is still 35%. Okay, then they show you a keyword here, use an approximation. Okay, so when you see this word in AS statistics 1 paper, and generally it means that you need to change the binomial become normal distribution to calculate for the answer. All right. Okay, so from binomial, you want to change it become normal, right? So how to get the mean? So to get the mean, it is n times p. So n times p should be 42. Okay, so maybe for this one, I write here. So to calculate the mean from binomial, right, it is actually n times p. How about the variance? So the variance will be NPQ, so which is 27.3. So again, this is variance. So variance for binomial distribution is NPQ. So if you multiply N, P, and also Q, which is 0.65, then you should be able to get 27.3. Okay, then now they are asking for more than 32 of this household has no broadband service. So that means X more than 32. All right, and you want to find out the probability for this more than 32, and then please take note that more than means 32 is not included. So you can see that there's no equal sign here. All right, okay, so binomial, when you want to change it become normal distribution, binomial is discrete random variable, and the normal is continuous random variable. So from discrete, when you want to change it become continuous random variable, you have to do continuity correction. So when you apply the continuity correction, it is either plus or minus 0.5. So for our case here, it will be plus 0.5, which is 32.5. All right, and then since you know that this is in normal distribution already, then to find the probability, you need to standardize it. So change it become Z. Okay, so how to standardize it? You need to minus the mean divided by standard deviation. All right, and after that, please make sure that you press calculator to get the value for Z until 3 decimal places, which is negative 1.818. Okay, so why is it we want to keep it in 3 decimal places here? It is because of in our table, right, we can find the probability for the value of Z until 3 decimal places. So we find until the maximized decimal number, decimal places. Okay, right. So to find the probability for Z greater than negative 1.818, you should know that it is actually equivalent to Z smaller than 1.818. All right. And from the table, now we want to find out where is the 1.818 here. Okay, so again, you are looking for 1.81. So when you try to find the value here, it will be 9649. And then 818. So 8 is this one. In the last digit, you need to add on 6. So which means 9649, you need to plus 6. So from here, you get 9655, which means the probability will be 0.9655. And of course, if you want, you can change it become 3 significant figure, and therefore you should have 0.966 as your final answer, which is in 3 significant figure. All right. Okay, so here we ended our 7 questions, all the questions for this paper.